be easier for me to just make a quick video for that problem we didn't finish in class than to write it up, scan it, and email it to y'all. So we're going to work out the last problem from the notes, and it's a piggyback problem from example 3. So our revenue function that we derived in problem 3, we're going to reuse. They've thrown in a new cost function for us, and we're going to use the same price-demand equation as example 3. And in this problem, we're asked to find the maximum profit, the price the marker should be set at to achieve the maximum profit, and the number of markers that will be produced to achieve the maximum profit. So we need to start with step 1, which is to figure out our functions. So my template here is that I need to maximize profit subject to the constraints on X. And X is the number of markers being sold, made and sold. So for the profit, I have to know that profit is revenue minus cost. But luckily, I have both of those functions right here. So finding the profit won't be too horrible. And we found our constraints on X in the previous problem. So we know that the number of markers that are made and sold has to be between 0 and 10,000. So those are going to be the endpoints on my sign chart later. So we're ready to start step 2, which will be to find the marginal profit, take the derivative of the profit, and find our critical values. So I'm going to first find my profit function based on the revenue and cost functions. Then I'll take the derivative of it. So profit equals revenue minus the cost function. I put the cost function in parentheses because it's a binomial, and I'm going to have to subtract the entire cost function. So I'm going to have to subtract both pieces of that binomial. So that gives me a profit function of 10x minus 0.001x squared minus 5,000 minus 2x. And I have some like terms I can combine to get the most simplified profit function possible before I take the derivative. So I'm going to combine these like terms, and I can see that profit is equal to 8x minus 0.001x squared minus 5,000. So we are ready to take the derivative of this function because it's a single variable. We didn't have to do any kind of fancy plugging in. We can just go straight to the derivative. And that will give me 8 minus 0.002x, technically minus 0. And now to find the critical values, I want to know when is this derivative either undefined, which will never be the case since I have a polynomial, or when is the derivative equal to 0. So I'm going to set this guy equal to 0 to find the critical values. And let's see, that's going to be 8 equals 0.002x, and 1, 2, 3, 1, 2, 3, divide by 4. Guessing that's 4,000, but y'all know me, so I'm going to use the calculator. Yep, it's 4,000. So I only have one critical value in my interval. So I could use a fancy test if I wanted to, but I'm going to make a sign chart and just verify that this is indeed a maximum. And then we will answer the 3 missing pieces of information that the prompt asked us to. So in my sign chart, I know at 4,000 markers, my marginal profit is 0. And before then, it will be positive. And after that amount, I'm going to test a number like 5,000. That would be negative. So indeed, I do have a maximum amount there. And since 4,000 is the only critical point on my sign chart, I know that this is also the absolute maximum of the function. So I can answer the maximum profit based on an X value of 4,000 if I plug that 4,000 back into my profit function. So that's what I'm going to do to answer the maximum profit. I have technically already found how many items should be produced to maximize the profit. That's 4,000 markers, so I can fill this one in. And I can use this X value to find my price that I should set the markers at to maximize the profit and what that maximum profit will actually be. So I'm going to plug my X equals 4,000 into my profit. And just heads up, this was technically step 3 right here. And answering these questions is step 4. So I'm going to find profit of 4,000. And to save space, I'm not going to write it all out, but I'm plugging that 4,000 into the profit function. I'm going to plug it into the most simplified version, so I'm going to plug it into this one right here, because he's the most simplified. And I'm getting $11,000. So that would be the maximum profit I would experience given my constraints. And now to figure, oh, 1, 2, 3, oh no, that's good. And the only other piece of information I've been asked to find is the price I should set the markers at to achieve this maximum profit. And since this maximum profit is achieved when I produce and sell 4,000 markers, I'll plug that 4,000 back into my price demand equation to figure out what the price is. So now I'm taking my price demand equation, plugging in my X value, which was 4,000 markers, and that'll tell me what price I should set the markers at. $6. So if I set the price at $6, there will be 4,000 markers sold, and that will maximize my profit at $11,000. And next class we'll see this graphically so we can get a more intuitive idea of what's actually happening. Hope that helped.